Welcome to the last video of the day. Thank you for sticking in there, and I hope the quiz went okay. You'll definitely get some feedback, and I'll make sure to help you out if you feel like you didn't do so well on there. Again, the idea is for you to get ready for algebra, and so if there's some things you need to work on, you have some flexibility, and we could fix that. Let's start with our skill check. Give yourself a minute to go ahead and fill in those boxes. Okay, so 2 plus 3 is 5. That's bigger than 4. And notice the way that the sign is showing. Right? The way that I read this sign is that the expression on the left is greater than the expression on the right. Okay, on the next one, 17 is blank, 25 less than 23 less than 5, that's 18, so 18 is bigger. So that's going to go here. 1/2 and 1/4. This one might be counterintuitive, but actually 1/2 is bigger than 1/4. That's because 1/2 is 50% and 1/4 is 25%. You can draw a picture and see that. And also, a little bit not intuitive, is that negative 18 is bigger than negative 19 because negative numbers, the closer they are to 0, the bigger they are. You see on my screen that I have a ruler. I've put the rulers on the wooden table, and if you can just take a moment, go ahead and go up and grab one. You pause the video and allow the students to grab a ruler. We're not going to be measuring anything today, but we will be needing to make some straight lines because we're going to start to solve inequalities instead of equations. Obviously, the word in means not equal, so we want to talk about things that are bigger than or smaller than other things. And by things, I mean expressions. So I hope you have a ruler. Let's talk about what an inequality actually is. Just like an equality says that two things are equal, an inequality is something or an equation that compares two expressions that are not equal. Okay, so I'll give you a moment just to write that down. An inequality compares two expressions that are not equal. Again, pause if you need more time. The solution to an inequality is a group of numbers or a set that make an inequality true. Sorry for the yawning. Apologize. The good news is that everything that we've learned so far is still true when I want to solve this inequality. Let's read this out loud. A number y plus 5 is less than or equal to negative 6. And notice that the line underneath means that the left side could also be equal to the right side, but you can see that it could also be less than the right side. If I subtract 5 from both sides of the inequality, you'll see that y is now less than or equal to negative 11. That means it could be any number as long as that number is smaller than negative 11. What I'm going to do first is I'm going to draw a straight line, and this is how you graph the inequality. I take my ruler, just draw it on the screen like that, making a completely horizontal line. I'm going to give you a minute to do that on your paper. Right underneath where I did my work, I'm going to draw a line that's completely horizontal. Then I'm going to put a 0 mark on that line. This is going to mark where the positive and negative numbers separate. There's 0. Now would negative 11 be on the left side of 0 or the right side of 0? Good. Left side of 0. And notice that I'm not making this to scale. I'm just picking where I think 11 should be. Negative 11, I should say. Now, what I want to do then is just draw a picture that represents all the numbers that are smaller than negative 11, including negative 11 itself. So you see I have an open dot and a closed dot on my screen. Because I want to include the negative 11, I'm going to use the closed dot, and I'm going to place it right above or on top of negative 11. I like to put it above just because I think it's easier to see. If I want numbers that are smaller than negative 11, which direction is smaller, left or right? You should be saying left right now. So I'm going to take my ruler and I'm going to take my pencil, and above the spot where my dot is, I'm going to draw a thick line with an arrow on it showing that I want all the numbers that are smaller than negative 11, including negative 11 itself. So if I pick any number now that's where this line and dot are, it would make this inequality true. For example, if I just pick randomly and just say way out here somewhere, maybe that's like negative 18. If I put negative 18 into the inequality for y, negative 18 is less than or equal to negative 11, that would make the inequality true. So literally, all the numbers on the number line below my graph, which I just put on the screen here, would make this inequality true, including the negative 11 because my dot is filled. If that dot wasn't filled, I would not include the negative 11 in my answer or my group of answers. Let's look at some other common inequalities. Notice that the book tends to put their graphs right on top of the number line. It's really up to you. How would I read this? That's a number x. That's 3. What does this sign mean? It means that the number x has to be less than 3. I want all numbers that are less than 3. And look at the way the graph goes. I have an open circle at 3 because I can't include it, and I want all the numbers that are to the left or smaller than or less than. Less than is left. That's how I remember. Less than, left. Okay. How do I read this? Y, 2. Y is greater than 2. Y is greater than 2. I want all the numbers that are greater than 2. Notice that there's no line underneath, so I don't include the 2. It's an open circle. Numbers that are greater go to the right. Greater, there's an R there. Greater means right. Okay. I have a number z, and that number z is less than or equal to 4. And now look at the difference. It's less than 4, but the circle's filled in, so 4 is actually part of the solution. Again, less than is left. Did you notice that? If I read it and it says less than, you go left. Okay. And finally, I want all numbers greater than 2 or equal to 2. And there you have it. You can pause or rewind if you need to. The freezing point of water is 0 degrees Celsius. At temperatures at or below the freezing point, the water is solid. It's called ice. Write an inequality that gives the temperatures at which the water is solid. Well, of course, it has to be 0 or less. So T has to be less than or equal to 0. On a number line, I would draw 0 and draw all the numbers that are less than 0, including 0 itself. Again, I'm going to give you a moment to pause and copy that down. All right, it's time to solve and graph our own. So I have n plus 5. M plus 5 is greater than or equal to 10. First step, subtract 5 from both sides. M is greater than or equal to 5. How would I read that? I want all the numbers that are greater than or to the right of 5. There's the number line. Here's 0. There's positive 5. I put a solid circle in there, and it wants to go to the right because it's greater than. You can check by picking any number that's bigger than 5 and putting it in for m. They chose 8. 8 plus 5 is 13. That is bigger than or equal to 10. The addition and subtraction properties of inequality are also true for inequalities involving the greater than or less than or equal to or greater than or equal to. Here's another situation. So I'm going to add 12 to both sides. Now notice the x is on the right side of the equation now. You say that 2 is greater than x. Now this is kind of misleading because I don't want numbers to the right. I want x less than 2. I'm reading it where the variable is. I'm not going left to right this time. I'm reading where the variable is. And I could read this right to left, like they do in other languages. I believe they read right to left in Arabic. I think they do that in Hebrew and in other languages also. In math, you could read right to left sometimes. This is one of those times. It says x is less than 2. I want all numbers that are less than 2. So if I switch that around with a commutative property, notice the sign switches also. And that might help you when you're graphing. If you like to have the variable on the left, that might help you out. And there's the graph. Now again, you're going to have to pause and make these graphs. I'm going to give you a second to do that just to practice. Again, make the line, make 0, write 2. So I'm going to just do that process on screen right now. So I'm going to just pretend like I didn't have that graph there. So I'm going to take my pencil. I'm going to make the line. I'm going to add a 0. I'm going to put 2 where I think it should go. I'm going to put 2 here. And just to make it easier to read, that should be 2. I'm going to try again. I'm doing this with my fingers, so forgive me for that. And it has to be a open circle because there's no equality underneath the inequality sign. So I'm going to put an open circle here, take my ruler, and I want numbers that are less than 2. So I'm going to take my pencil, go to the left, just like you see on the screen picture. I'll put the arrow on the end to let you know that it goes on forever. And we're done. Okay, it will take some practice, so make sure that you get okay with your ruler. It doesn't have to be completely horizontal, but I like to be because I can. Let's do some practice now. Again, pause the video, solve the inequality, and then graph it. First inequality is n is greater than 4. Second inequality is 6 is greater than y. Third inequality is 3 is less than or equal to x. Final inequality is x is less than 6. Now to graph these, again, I have to be careful. First make the number line. Mark where 0 is. Where's -4? Where's the variable? It's on the left side, so that's where I'm going to start reading my inequality. My numbers are greater than 4. Open or close circle. There's no equality, so it'll be an open circle above. And I want my number to be bigger or greater than, so I go to the right. Okay, next one. Oops, didn't get straight that time. Let me move it back. Now, will I read this right to left or left to right? Where's my variable? Variable's on the right side. So I'm going to read this right to left, and it says that y is less than 6. So I'm going to graph where 6 is. There's 0. 6 is maybe over here, we'll say. Open or close circle should be open. There's no equality. Now I want my number to be less than 6. Y is less than positive 6. So I'm going to go to the left. Okay. Let's do this again. You see now that my variable x is greater than or equal to 3. So, number line, mark 0, mark 3. This time I finally have a closed circle because there's equality. Okay, and then I go to the right because I want numbers that are bigger than 3. Alright, and for lack of time, I'm not going to be able to graph this one, but I want x is less than 6, so it should be an open circle at 6 and should go left. Okay, our last example, and again, I'm going to go through this quick. You're going to have to rewind and pause this. I only have about 1 minute left in my recording. Just know that in a triathlon, you want your swim plus your bike time plus your run time to be less than last year's total. And you see that last year's total was 85 minutes. It says that you took 17 minutes to swim, 45 minutes to bike, and you want to know how long can you take running so that you still beat your time. I combine the like terms. That's 62. So R is smaller than 85. So R has to be less than 23. I have to run less than 23 minutes. Pause and go ahead and do the examples. Okay. Again, I don't have time to go through the graphing, but you should have hopefully got that by now. Here are your simplified inequalities. And here is the answer key to the last question. Again, I apologize for being so brief at the end, but I'm out of time. Have a great weekend. I'll see you on Monday. Thanks again.